Well, ladies and gentlemen, good afternoon. I know that you're absolutely on tenterhooks to know who won the debate in the House of Lords and what the final vote was. The truth is, I have no idea. I haven't actually looked at my text message, which will tell me whether the government won or whether the opposition won. But maybe at the end I might allude to it. It's my pleasure, unfortunately, as of course, as you know, Sam Gyimah, the Minister for Science and Universities, is obviously not here with us at the moment because he resigned over the weekend. So it's my pleasure really to invite John Lufthead, who is the Chief Scientific Advisor to the department, if he would give Sam's, a lecture on Sam's theme, and that would be, actually, I think it's very, very apt that you're doing this, really, as an engineer. That's great. Thank you.
Well, thank you very much, Lord Winston, and I hope you will be able to contain your disappointment at not having the Science Minister here, but as the Chief Scientific Advisor at the Department for Business, Energy and Industrial Strategy, I'm stepping in today as we wait for confirmation of the appointment of the new Science Minister. However, it's wonderful to be at such an appropriate venue, the home of the Institution of Mechanical Engineers, which, along with many other institutions represented here this evening, plays a pivotal role in the UK's endeavour to be a nation of innovators. And for me, it's particularly appropriate because my first degree was in mechanical engineering, and I am actually a fellow of this institution. So I'm delighted to see you contributing to its target income in this way. But of course, we are here this evening to celebrate the Newton Prize and the excellent research and innovation that comes from international partnerships. And I'm delighted that I've already seen both familiar faces and new ones in the audience tonight. And I'm particularly pleased to be able to welcome some of our international guests, including ambassadors and high commissioners from the Newton Fund partner countries and the overseas partners for the 2018 Newton Prize winning projects. So we certainly are global this evening. Well, as I've already said, I'm an engineer myself who's been working in both engineering and science in the industrial, academic, and now the public sector for quite a few years. And one thing I've concluded from that is the undeniable and large benefits that come from international collaboration in all its particular forms. Science has no boundaries. It has no borders. And the best science is done by working internationally. International partnerships bring together the brightest thinkers and innovators and mix cultures and concepts in order to solve key global challenges and hopefully change lives now and for generations to come. And in my view, the Newton Prize and the Newton Fund certainly brings this to life. And I'd like to take this opportunity to congratulate all the Newton Prize shortlisted and winning projects for 2018 on their excellent work and the lasting partnerships I'm sure will have been forged. Those projects Thank you. You see, I'm very inexperienced. I don't expect people to clap when I speak. But of course, you're not clapping me, you're clapping them, and rightly so. The projects reflect the breadth and depth of the Newton Fund work and are a very powerful advert for the important role the fund can play in tackling global challenges. For all their work in managing and assessing the awards, however, I want to particularly thank, firstly, the United Kingdom National Commission for UNESCO, who managed the process, the independent Newton Prize Judging Committee members who did the work, and finally, but by no means least, Sir Venki Ramakrishnan for the great work you've done as the Newton Prize Committee Chair over these last 2 years and getting this thing off. Thank you, Venki. So this annual £1 million Newton Prize was created to celebrate and further encourage the partnerships that UK researchers have forged with their colleagues in Newton Fund partner countries. These international collaborations illustrate how we're working with global partners to tackle global challenges, finding innovative solutions that not only change lives for people in those countries, but wider and beyond. When our researchers talk about the benefits of international partnerships, they talk about exchanging knowledge and experience, about having access to scientific facilities that may not be available locally, about building and maintaining trusted and personal friendships between researchers, and finally, and most importantly, how scientific collaboration with and between countries is genuinely helping to solve regional and global development challenges. This is exactly what the Newton Fund was set up to do. That is our mission, and it is, I believe, the international spirit of science. So it's for that reason that I'm pleased to share with you this evening that in 2019, the prize will be returning to Asia after this year's focus in Latin America. And the countries are China, Indonesia, and the Philippines. These three countries have all been partners in the Newton Fund from its outset in 2014, which has helped to transform the UK's science and innovation partnership with them, delivering solutions to global developmental challenges in areas such as agriculture, climate resilience, and public health, but doing that through excellent science jointly done by our researchers. And it's also having a lasting impact on how science is delivered in countries. For example, the partnership in Indonesia has supported the establishment of a new funding council with ambitions to support Indonesia's future Nobel Prize winners. And we wish them the very best of fortune in that ambition. International collaborations such as these will be increasingly important as the UK leaves the EU. We want to continue to deepen our existing relationships and to develop new collaborations to foster science excellence and economic growth, not just within the UK, but across the globe. That's why the UK announced in its industrial strategy that we would develop a new international research and innovation strategy. It will be ambitious, and it will set out how, through global collaboration and the UK's attractive research and enterprise environment, we will strengthen capabilities to help achieve the industrial strategy's long-term vision. We're sure this will be a priority for the new Science Minister when she or he shortly arrives. Later this week, we'll be celebrating the first anniversary of the modern industrial strategy. In that strategy, the UK committed to the biggest ever increase in public and private investment in R&D. The UK has set a specific target of 2.4% of GDP spent on R&D by 2027, and to reach a figure of 3% beyond that. This represents a step change in level of investment and is intended to enable us to stay at the cutting edge of research and innovation, providing high-quality, sustainable solutions to challenges both here in the UK and globally. It also outlined grand challenges. We said that we would take these on, and those are the society-changing opportunities and industries of the future. We have 4 grand challenges, which are the initial set, which are focused on global trends and aim to transform our future in the areas of artificial intelligence and data, in the aging society, in clean growth, and in the future of mobility. And every single one of those areas will require partnerships internationally. So I'd like to close by saying that science and innovation, both domestically and internationally, is now more important than it's ever been. The research we shall celebrate this evening shows how powerful collaboration can be. And I look forward to us in the UK working with all those partner countries together for many years to come. Thank you.
Well, I mentioned it was a privilege to introduce the Newton Prize earlier this afternoon, but it's also a great privilege to introduce Sir Venki Ramakrishnan, who, of course, is a remarkable model for a scientist, because it seems that he has encompassed not merely physics, but also biology and a whole range of other things. And, of course, one of the things he's also worked on, one of those mysterious organelles we see in cells, the ribosome, which, of course, is responsible for protein metabolism. He did his first degree in India. He moved to Ohio. He ended up then in Yale. Then he moved to Brookhaven, and finally, of course, to Cambridge, where he still is. And Sir Venki really needs no introduction. He is, of course, now president of the Royal Society and has been so for 3 years. He's a member of EMBO and a member of the National Academy of Sciences in the United States. So it's a huge pleasure and a privilege that you're here today to present the Newton Award. Thank you for coming.
So thank you very much. About 2.5 years ago, soon after the country had its referendum, I received a phone call from Joe Johnson, who was the science minister at the time, and said that they were planning to institute a prize connected with the Newton Fund, and would I be willing to chair it? And I felt very strongly that it was an opportunity to show that regardless of the politics of the country today, Britain has for a long time been a highly open society that has collaborated with lots of countries all around the world. And the Newton Fund in particular was an effort to bring together UK scientists and scientists from a group of countries where we could work on common problems. Sometimes the UK scientist would provide a certain technology or expertise, but the problem might be related to the other country. But it isn't quite so hard and fast. It's really more a question of two groups or two scientists getting together and saying, look, what can we do together that can help with some important problem? And so I did agree, and so I've chaired the prize committee for 2 years now, and I'm stepping down, and there will be a new chair next year. So just to give you my sort of experiences, the first set of countries was in Asia, and it was a different combination, but it included another large country, which was India. And this year, we have focused on Latin America. And for those of you who are visiting from Spanish-speaking Latin American countries, I would say, bienvenido al Reino Unido. So the experience, although the countries were very different, there were some common themes. The first thing is that we realized that on the jury, we really simply didn't have the breadth of expertise to actually make expert evaluations of sometimes any of the grants. For example, there would be nominations for which there was no expert on the panel. So how do we go about that? Well, the first thing is, even before we meet, we try and get expert opinions from people in the field, and then they tell us, what is unique about the project, what have they accomplished, what do they think, where is it going, etc. And then comes a more difficult task, which is, could roughly be put as comparing apples and oranges. How do you judge whether, a particular project on water conservation is, how does it compare with something else that does with genetics of, some human disease? It's a very tough sort of decision. And in the end, we had to look at a number of criteria. First of all, how important is it on a global scheme? And how well have they done? And do what they want to do with the proposed, prize money. Does that make sense? Is it a real, just a little extension, or would it be a really, significant advance over what they're doing? So these are some of the criteria we used. But I have to say that if you look at the shortlist, even a slightly different jury might have come to a different conclusion about the order. And so really, some of you who know me know that I'm somewhat ambivalent about prizes for that reason, because in science, it's not a thing like the Olympics where you can measure who came first, second, and third. It's a multidimensional kind of evaluation, and so we shouldn't take it as if it was a sporting contest, but rather we should take it as an opportunity to highlight important science. And so those of you who didn't win, were on the short list but didn't win, you have to realize it was a very tough call, and you should really be proud of having accomplished what you did. And those of you who did win, you have to keep in mind that on another day and another jury might well not have given it to you, okay? And so you should take this more as an opportunity to sort of use the prize and really do something interesting and useful with it. So that's all I would like to say, and I guess I'm supposed to now hand it back to Lord Winston. Thank you very much.
And of course, ladies and gentlemen, I should have pointed out that Cervenka is incredibly modest because, of course, as you know, he won, talking about prizes, he won the Nobel Prize in 2009 for chemistry. So, do you think it would have been different with a different jury? Anyhow, it's my pleasure, ladies and gentlemen, to introduce now the Newton Prize winners. So we're going to start off with a short introductory video, which I think will be shown up here, hopefully, if the projections work, and then I'll introduce the first team. Just like my mobile phone.
Tiene una historia sísmica y de hecho en su historia se registran los peores terremotos que han ocurrido en la historia de la humanidad. Básicamente eso nos llevó a inspirarnos y a hacer estos modelos matemáticos que permiten enfrentar y dar cuenta de la ocurrencia de estos eventos naturales dentro del proceso de planificación de redes eléctricas. Y hemos tratado de dar respuesta de cómo llegar con un mejor producto y una mejor calidad de servicio a la gente enfrentando este tipo de desastres naturales.
We have proven for the first time that you can use coffee waste to produce electricity and to clean the water or clean the waste coming from the processing of the coffee. We are very excited because in 9 months we were able to set up a system, a working system with coffee waste, and we also were able to set up a very low cost device using domestic material, household materials. That was very exciting because we didn't expect that to be successful so quickly.
Mexican agriculture is strongly affected by drought stress, and climate change is making matters worse, particularly for beans, a major Mexican crop. Our work aims to improve bean drought resistance by improving plant water use. Our Newton Prize project also focuses on improving bean nitrogen fixation under drought and reducing farmer reliance on fertilizer inputs, which will in turn improve soil and water quality. We hope these findings can contribute to improving food and water security in Mexico and across global agriculture.
Well, I think it's my pleasure now to invite first of all, the Brazilian team up on stage, if you'd come. Thank you very much. So you're going to present, and then you'll answer some questions from the audience?
Absolutely. So I think we have a presentation that should come along. Well, maybe we should just say that, of course, we represent a whole team of people, and this is very much a team effort that has resulted in this work. And it's something that has involved not just scientists, anthropologists in the UK and in Brazil, but also indigenous people. And part of the idea and philosophy behind that is that many of the objectives of the Sustainable Development Goals are being reflected upon by the very same process which has created many of the problems that we seek to resolve. And one of our beliefs is that at the Center for the Anthropology of Sustainability is that we need new thinking in order to really address these in very effective ways. And much of that new thinking comes from indigenous people. And so the work has been conducted between the UK, between Brazilian anthropologists in Cetii, and also the Guarani people of the Atlantic forest and the Ashaninka people in the Amazon forest. The Guarani are the largest indigenous group of the Atlantic forest region, but more than 90% of the Brazilian Atlantic forest is gone. The project addresses this in two complementary ways: restoring the Atlantic forest itself and addressing the territorial and environmental vulnerability of the Guarani. The Atlantic forest is fundamental for the Guarani's physical and cultural survival and to the quality of life of more than 70% of the Brazilian population that depend on its preservation for access to secure water provision for their cities. In our projects, we always make sure that before any activities begin, we involve all the stakeholders in discussing and deciding what actions should be taken. Guarani villages very often protect the last fragments of the Atlantic forest that still exists, but the aggressive expansion of cash crop plantations is putting severe pressure on the remaining forest, on Guarani livelihoods, their health, and their well-being. Intact Atlantic forest in Argentina is protected and maintained by Guarani. To restore lost traditional foods varieties, the Brazilian Guarani suggested that they visit their Argentinian colleagues to obtain seeds unavailable in Brazil. The project facilitated the first trip, and the Guarani have continued to strengthen these relations since then. These coloured corn seeds gifted to the Brazilian Guarani are considered to be the food of the gods. Exchange visits were organised between Guarani and Ashaninka from the Amazon. First, the Guarani visited the Ashaninka to learn about forest restoration. Then a year later, the Ashaninka came to see the progress made by the Guarani in their communities. The Guarani presented them with food of the gods seeds to plant in the Amazon. Following this success, the project organized agroforestry workshops to restore the Atlantic forest and to adapt slash-and-burn agricultural techniques to the shortage of forest by planting more nitrogen-fixing species and new mulching techniques. Today, Brazilian politicians refuse to recognize and respect indigenous peoples' land rights and environmental conservation. The new president has twice publicly described indigenous people as zoo animals, rejects the need for environmental impact assessments for major infrastructure projects, has cancelled the COP25 climate conference planned to be held in Brazil, and wants to remove Brazil from the Paris Accord of 2015. Mapping resources and land rights is a vital first step in the process of defending lands and forests. The project has supported Guarani to map 7 traditional territories. Partnerships for knowledge exchange are a central pillar on which these successes have been achieved. These range from international ones, such as between the Centre for the Anthropology of Sustainability at University College London and CETI, between Argentinian and Brazilian Guarani, and between Ashaninka and Guarani, and between Guarani communities in Brazil. Publishing these territorial and environmental management plans are the end product of these complex processes. The Newton Prize will enable us to put these plans into practice and begin them in several new communities over the next year. Plans include reintroducing original Atlantic forest species endangered by forest loss. These include insects as well as plants, and here the Jatai bees that are vital pollinators for many of the indigenous plants unique to the Atlantic forest are very severely menaced by agricultural chemicals and land change. Jatai honey is another of the food of the gods. The project developed resources to remain in Guarani communities. This Guarani-made film, for instance, documents conflicts with commercial farmers so that others, less affected communities, have tools to deal with these issues if they emerge in their area. The illustrated guide on the right explains how to manage exotic species so that they do not undermine the reforestation of indigenous species. Thank you.
Sorry, I'm rude enough not to introduce you properly when you came up. Dr. Jerome Lewis, and you know, if you forgive me, your name is quite complicated. Daniel Calazans-Pieri from Brazil. Thank you very much indeed. I don't know whether people would like to ask about this hugely important problem with the gradual loss of the Brazilian rainforests in general. Maybe I could just kick off, because we've got about 5 minutes of moving on, is that right? So. Where are we going? What can we finally do about what's happening to those forests in general?
I'll try to answer, and I'll start excusing for speaking such a bad English.
This can be better than our Portuguese.
Okay. And that's a very difficult question. I guess we are talking about in this project of a rainforest, which is called the Atlantic Forest, which no one hears about because the Amazon is more known in the world, the problem in Amazon. But as we told in the beginning of the presentation, 90% of the Atlantic forest is already gone. And there's where the Guarani communities live. They depend on these lands to their well-being, and there are very conflictuous problems of land in this region. And when we talk about all the CDG goals in Atlantic forest, we cannot talk only about forest conservation. We have to talk about forest restoration, because the Atlantic forest is almost disappeared, and this is a thing that this is what I think is more important to say on
what
this
are the
subject.
relative areas of the two areas of the country?
The Atlantic forest was, as as big as Amazon. It takes all the southeast states from Brazil until the northeast states. So it's a very large region where the biggest cities are located and the biggest farms and industries and roads, and there are too few fragments of forest which remains, and is on these fragments where the Guarani communities try to live until now. So it's a very big problem.
Could I just add something?
And at UCL, how did you get interested in this area?
Well, a lot of the scientific research on forests and forest restoration is coming to the conclusion that you can't understand forests as sets of individual species, but they are co-emergent through a whole range of complex biosocialities, is what we call it, that encourage the abundance of different species, and their interaction is what creates healthy forests. And one of those key species are people. And this is quite contrary to the assumptions of much Western conservation, which assumes that people are the problem. And so we take the approach that we need to support indigenous communities in particular, because they have established long-term relationships with landscapes that ensure their flourishing. And it's through encouraging and supporting indigenous people's land rights, their ability to practice their traditional techniques of agriculture, to support them with the diversity of seeds that they are used to growing, that we can actually make much more of an impact in restoring forests than simply by isolating areas and thinking that we can replant individual species in some sort of, old-fashioned nursery-style reforestation.
So before I ask Cervenki to present the actual trophy and also perhaps to ask his own questions, I don't know. I wonder if there's anybody in the audience that wants to raise anything. Yes, please.
I just wanted to ask if you were part of the UNESCO Man and Biosphere programme, and if not, if it's something that you might think about joining.
Well, we're not, but we will certainly think about it. Thank you for the invitation.
Anybody else?
Yeah, thank you. I'm Claudio Beñor Rosso from the University of Surrey. The question is, when you said you need to introduce the human species as part of the ecosystem, part of the human species there have been growing soybean as a monoculture, displacing the maize, and how are you going to do that?
Well, what we've found, the studies show very clearly, and this is perhaps Brazil is one of the classic examples, that where indigenous people have managed to have their land rights recognized and protected, that it is far more effective than any government program, than any NGO program, that they really are the best guardians of biodiversities. And so that's how we have to work. Unfortunately, the odds are stacked against us because big money is behind the monocultures. But I think it's in everybody's self-interest in the long term that we create much more space for these indigenous groups to reconnect with their environments, to start re-establishing those key relationships on which those environments depend for their flourishing.
Perhaps I could ask Cervenki to come and award the trophy, and maybe you've got a question you want to ask as well.
Let Daniel. Thank you very much.
Thank you very much indeed. Congratulations. Wonderful. So our next prize winners are from Chile, and this is in the UK Chile category, and there are long electricity blackouts which have a massive impact on the country's economic activity, social stability, and of course the security of the country. And so what I'm going to ask is for Professor Pierluigi Mancarella and Rodrigo Moreno, who's the Associate Professor at the University of Chile, to come and present their project, if you would. Thank you very much. Congratulations to you. Wonderful. Thank you.
So, good evening, ladies and gentlemen. It's a great pleasure and honor to be here to present our work on resilient planning of low-carbon power systems. So I'm Pierluigi from the University of Manchester, and Rodrigo here, my colleague from the University of Chile. And we want to tell you a little bit how this all started, which is with this project, of course, supported by IPSRC and CONICET, with a partnership with the University of Manchester, University of Chile, and Universidad Católica, where we wanted to understand actually how we could make the power system of Chile more resilient, so able to withstand and respond to extreme events, and what events in particular and why Chile.
So one of the main inspirations of this project is what happened in Chile in 2010 with a very large earthquake and tsunami, and that really changed the way how we see, understand, and face these natural hazards. As we can observe, these natural events has a very catastrophic consequence or implications on critical infrastructure, and therefore on our ability to deliver basic services at a national scale. Of course, this is not only about critical infrastructure, but also on the very large impacts that these events have on society, communities, and cities. One of the main or key technical innovations from the project is really trying to resolve this, what we call the resilience trilemma, which attempts to balance whether to have or make a network stronger, bigger, or smarter. Stronger by upgrading or hardening existing infrastructure, bigger by adding new infrastructure and adding more redundancy in the system, and smarter by adding new technologies. So we developed these advanced mathematical modelings to find the appropriate balance between these three.
But of course, it's not only about the engineering. There's also the impact on real people, so real world, actually what earthquakes can create. So we developed quite part of projects looking at what we call negative community resilience. So actually what bad things can happen within communities, but also what we call positive community resilience. So actually how communities are helping through cooperation, solidarity, social networks to make the system more resilient. And here you got some examples of basically how communities self-organize and support the recovery of the system. So we very quickly realized that engineering were not sufficient to address this issue of resilience. So we need to rethink planning way beyond engineering. So we introduced communities and modeling of communities as a part of long-term resilience plans, which is key, particularly in developing countries. And in a way, we developed what we called a socio-techno-economic perspective of planning. As I said, goes well beyond of engineering, because the engineering tools were not sufficient, as I mentioned, to actually address this huge issue. Now, we are applying a new methodologies to different countries, different applications. First of all, through the Newton Prize, with application to Chile and Costa Rica, looking particularly at flooding and landslides. And we also have another project sponsored by within the GCRF scheme, which looks at the impact in Malaysia and China. So really trying to broaden the impact, trying to apply a methodology widely around the world. I just want to conclude by saying that, of course, this would not have been possible without support of many people, many institutions, particularly system operator in Chile and the Ministry of Energy that worked very, very closely. Of course, our own academic institutions. Also wanted to thank particularly a colleague from the University of Manchester, Dr. Matteo Spantelli, who's there in the audience, who supported the project from the very beginning. Thank you.
I mean, you mentioned a trilemma. Of course, you've also got a country which is divided, a hugely long country, which is divided into 3 completely different zones, from very high up, of course, in the Andes, down to the dry coastal plain. Does that have any relevance to your modeling and your planning?
Yeah, absolutely. Well, this is now becoming a bit technical, but if you see the Chilean network and you put it on Europe, you'll see that go all the way from North Scotland to Morocco.
Yes,
in Africa.
It's a long way.
So it's technically speaking, that's a very hard network to manage. And of course, finding these investments in, let's say, operational decisions that will make the system more resilient was very challenging, and that's why we came up with these mathematical models.
And if I may add, actually one of the main findings will also be that a high voltage DC interconnector, which is one of the options we also discussed here in the UK, could actually even be put forward because of resilience. So maybe for normal planning, it may look a little bit expensive, but then we demonstrated that technically that actually such investment would be worth in the case of earthquakes, because it would make the system significantly more resilient in the case.
Thanks, Pierluigi. Some questions?
Philip Greenish from the University of Southampton. Could you give us an idea of what it would take to, in terms of resources and time, to implement the thinking that you've been working on?
Okay, so very pleased to say that already within the project, after 1 year of the project, actually system operator took the methodology we're developing and already introduced changes in the grid code for investment into some specific devices that were not invested otherwise. They soon realized, looking at our methodology, but that still was under development at the time, that there was absolutely something to do, because in the case of earthquake, it would have been a disaster. So partly it's already been implemented. Of course, now there are a number of options that we proposed in the project, and maybe, Rodrigo, you may add something more specific about what this.
Not really.
So yeah, I mean, that's
wonderful.
No, well, I mean, the idea, but then the idea would be that, of course, the more we look at communities, the more we think that there is a future for them, as I was mentioning, within system planning. This never existed anywhere in the world. So there are big discussions about microgrids. So basically, how little sort of small islands managed by communities could actually support the system. So we demonstrate in this project that actually they would make sense. All around the world, there is a struggle to understand if these microgrids should happen or not. We clearly demonstrated that they are a very, very important option, potentially. It's not only a technical option, it's a social technical option that this would represent.
Well, probably now I can add something small. No, I mean, just to say that it's really about understanding the benefits of what the measures you are trying to develop in this particular case, on the electricity networks. So before we saw all these investments or all these new technologies like something very expensive, or probably something you may justify because of renewables, and there are very specific issues going on with flexibility and renewables. But now we saw another angle, and we actually can manage and see what's the value of these new technologies or something slightly more expensive decisions, but that can deliver great value in terms of hedging and providing some sort of coverage against natural disasters. So.
Thank you. I was very interested about the slide where you pointed out that there are negative social and positive social aspects to resilience. And I just wondered if you could clarify a little bit how your project addresses those different issues.
Yeah, so we had some colleagues, actually experts in disaster management, whose job was really to go down to the communities and understand what, for example, happened during the big earthquake that Rodrigo was mentioning. And it was extraordinary to find out, for example, that when you looked at system recovery, we could come out with all sorts of technical engineering options, and then suddenly you would realize that you could not apply them simply because communities would not allow anyone to get into a village, for example. There's a substation to repair. There's been an earthquake. people would not trust anyone, not even people saying, no, we're actually from system operator, we're here to help you, because it's really a crisis at the time, and these are sort of reactions that you would see, because people would steal, there would be any sort of crime going on, therefore you would try actually to help, but you could not help because of the situation. That's when we understood engineer was not sufficient, we needed to bring into planning some new aspect was sort of more socio-economic related in a way.
Thank you very much, Peter. Can I ask Svenka to come up? Thank you. Thank you very much. Thank you. And the next country is Colombia, one of the 4 countries that I spent the least time in, but it's certainly where I have perhaps the most interest because of, I pointed out this morning, my regular dose of Colombian coffee, which you're going to talk about now. So maybe I could introduce Dr. Claudio Avignoni Rosa to speak on what you're doing with a new form of energy.
Thank you very much. This project started as a collaboration between Dr. Lina Agudelo from the University of Antioquia in Medellin, Colombia, and my group at the University of Surrey here in the United Kingdom. And what we tried to do is join forces, and they were in that group. They were very familiar with the use of agricultural waste, whereas we were very familiar with the use of bioelectrochemical systems, in particular microbial fuel cells. And the idea was, well, coffee is the second most important commodity in the world, and there are more than 8 billion kilograms produced per year. Colombia is the 3rd largest producer of coffee in the world. And going from the farm to the cup, there are several steps. And those steps have some negative impact on the ecosystems. One of the problems is that we get something like 2 tons of wet waste per ton of coffee beans being produced. 1 cup of coffee requires, from the beginning until it's there in our cup, about 140 liters of water. And we drink in Europe 750, 700, something like that, million cups per year, some of them by our hosts. And this has a very negative impact on the ecosystem. There are large amounts of wastewater being released to the environment, and that causes a severe pollution, contamination, with, of course, the problems in the soil and the aquatic system, increase of water-related diseases, etc. So what we try to do is, well, let's see how much of this wastewater we can use in the system, went to the farms, and we decided to join that waste, and you can see up there the water coming out of the processing, and our experience with microbial communities that when they are introduced in a device called a microbial fuel cell, they will utilize the high content of organic matter in that waste to live, to grow, and that process is extracting electrons from the organic matter. So our cells do the same, but the electrons are transferred to oxygen. What we did is we hijacked those electrons in an anaerobic environment, so these electrons will go into an electrode. That electrode is connected to an external circuit, and what we have is electricity being produced. And what you can see there, you're going to see there, sorry, it should have. You can see a little flash there. That is the electricity being produced by the microbial community. This was the first experiment that showed that we could obtain energy from coffee waste. So the idea is that we will be cleaning the water, we will getting rid of this organic matter in the wastewater coming from coffee, we will release cleaner water into the environment, and we will, of course, produce a little bit of electricity. This is not going to light up this room, possibly, but it's going to be used for powering a monitoring device or a little system of lights, or perhaps some system to communicate with a computer, if we are able to increase the volume, or not the volume, but the number of units in the system. So with our project, we were able to develop a very low-cost microbial fuel cell that can be produced or built using material from, for instance, the local farms, local coffee farms in Colombia. So what we have done is try to build a system that can be multiplied, can be produced in large numbers to treat the water coming from coffee waste. So our project is then trying to set up a prototype in a coffee farm, and that will be done using the Newton price. Our project hits some of these SDGs. Environmentally, what we have is a possibility of decreasing pollution and reducing the impact in soil. From the sustainability aspect, we will have a system with less fuel and improved efficiency. And from the technological point of view, we will develop systems that can generate clean and green energy. So our outcomes, we think, are going to be both from the scientific and technical point of view, selection of microbial communities that can convert that waste into electricity with a much higher efficiency. We will design and scale up and install in a farm one of these systems to test the concept, to prove the concept. We'll have scientific exchange and training of researchers and academics, and of course, we will understand what happens in the system, that problems we can address to improve the environmental sustainability. But from the societal point of view, we think that we will generate knowledge and technology, we will create new jobs, and we will create new opportunities for the communities involved in the production of coffee. 95% of the coffee farmers are small family-owned units. We will liaise with the stakeholders. People are going to we are going to try to convince people to understand and to adopt the system and to extend it to other regions, not only in Antioquia, but the rest of Colombia, if possible, or other coffee-producing countries. And we will, of course, learn from the main actors, from the people working in the field. And, of course, that will bring some exchange of knowledge, which is what we think the most important objective of this Newton Prize. And this has been possible thanks to the funds received by Dr. Agudelo from the Newton Research Exchange Program, by the research councils in the UK, by the University of Antioquia and the University of Surrey, and fundamentally by society, because we are responding with the confidence they put on us when they give us money for our research. Thank you.
I'm sure the engineers here will be interested to know about the amount of energy you might be able to get from the given mass of waste. But let me just ask you about the effect on the biome and the agriculture. What was done with the waste previously? Was it just spread around on fields?
Well, I forgot to say that, but yes, normally the waste treatments to clean the water and to treat properly the water are very expensive, and those farms normally cannot use those expensive systems. So normally what happens is that the water is just thrown into a river or water body or to the soil, and that is a huge amount of organic matter and a huge amount of energy. That is energy that we are disposing of.
And the effect on rivers?
The effect on rivers is very serious because when you discharge organic matter into a river, bacteria will immediately consume that organic matter, the levels of oxygen decrease, becoming anaerobic, fish die. So what the other problem is that there is a mucilage being removed from the coffee bean that sticks to the surfaces, and the surfaces became, well, impermeable. So what happened is that there is no good exchange of water, the river becomes contained there, and it's a really serious problem. And of course, the smell is very bad, the effect on the society is very bad because people are living in a not ideal system.
Let's just see if the audience have got any questions. Yes, somebody.
Thank you. Vadgar McQueen, Mary London. It's really interesting that you're exploiting coffee in this way. You'll be aware of an awful lot of literature on bio-waste-based biofuel cells. So what do you think gives you the differentiating edge? Is it the availability of large amounts of bio-waste, its chemical composition, or you have a microbial group that works better?
I think it's a combination of all three. The amount of organic matter in the coffee waste has been calculated to be something like 15 gigajoules per ton or something like that, which is 1/3 of what crude oil contains. So the amount of energy is immense. And all these compounds are very easily biodegraded. So if you, as I said before, if you chuck them into the river or into the soil, they will rot. And that is a serious health and welfare problem. The type of microbial community we used, surprisingly, comes from an anaerobic digester. It doesn't come from a coffee farm. We couldn't import to the UK a microbial community from the coffee farm. Lina Agudelo, as we speak, she's trying to find the right microbial community from the coffee farm, and she's doing good advances in there. So it's a combination of all three. Yeah.
Yes.
Eric Alban, Clifton Scientific Trust. You said that 90% of the coffee producers were small family units. I presume this technology is geared to that sort of size. Presumably, though, among the 10%, there are very large corporations. And is this valuable for them, and aren't they the main problem?
Yes, I think
is that true? I mean, what I'm saying.
Okay, the big farmers that I have spoken to in Colombia, they are very much interested in environmental aspects, trying to produce in a green manner, sustainability, etc. They don't want to invest money in this, possibly, yet. But if we can show that this works, they will. We had some talks with people there, and they said they would be interested to see if that works. Now, the secondary processing of coffee, which is instant coffee, is 50% of the total export of coffee. And we believe that a similar system can be applied to the waste coming from secondary production of coffee. So the big companies from which we drink coffee normally, they would be interested in applying this type of technology. At the moment, they are doing only anaerobic digestion, as far as I know, and that produces methane. Methane can be used as a biogas, but it also goes into the atmosphere, greenhouse, etc., etc. So, yeah.
Yes, Bayo Adelaide from Heriot-Watt University in Edinburgh. Now, I just wanted you to clarify the difference between this new system which you've developed and the classical anaerobic digestion, which produces biogas, which you can then turn into electricity. Is there a major difference between the two?
Well, the difference is, as I said before, the difference is that biogas is a well-established system. Production of biogas is very well established, and you produce methane. The problem is that in those farms, it's very difficult to set up system for anaerobic digestion. And the water coming out of the coffee production, the solid waste could be very, very well used in anaerobic digestion. The liquid waste is more difficult because you are diluting the system. So our idea was to treat only the water initially to see how we can adapt this microbial fuel cell system for that. The other problem is that anaerobic digestion in the last few years has been considered to be a little bit risky because of the greenhouse gas emissions, but I'm not an expert on that.
Now, I have a timekeeper here. Have I got time for one more question? So there's somebody at the back of their hand up. I think I saw you first.
Hi, Carlos Ponce de Leon from the University of Southampton. Is it possible that you oxidize the coffee beans to a more environmentally bad material? Because you oxidize in the coffee beans material, and then you may produce some organics that are not as, well, more damaging for the environment?
Well, we don't use the coffee beans. What we use is the waste coming from the production of the coffee beans.
Okay, the waste.
Yeah. We think that the ground coffee waste, the coffee that comes out from the espresso machine in Starbucks or Costa, that can also be used. The problem is solids there are very difficult to move in the system. So we are not yet working with ground coffee, but we are thinking how to do that.
Talia, thank you very much. I should have mentioned you're working at the University of Surrey.
Surrey, yes.
Thank you. So thank you, if you would. Thank you. Thank you. So we come now to the UK-Mexico collaboration, really about a different kind of bean, actually, of course, the Mexican bean. And this is a collaboration between Sheffield and the UK. And we're looking really at something which, of course, is increasingly important, the general process of how we might deal with drought-resistant plants. And this is a very interesting approach to the leaves of the plant. So can I introduce, sorry, forgive me, Dr. Kasper Cheta from the Institute of Biotechnology at the Autonomous University of Mexico, and the University of Sheffield to present his work on that manipulation.
Good evening, and thank you very much to the Newton Fund for bringing me over from Mexico last night. I'm here to represent, of course. Oh, wrong way. There we are. I'm here to represent, of course, Alejandra Covarrubias, who's one of my bosses. She's my boss in IBT UNAM, and my other is Professor Julie Gray in University of Sheffield. So we started this project back in 2014, and since then it's been gaining momentum, and we've now got master's students and other students in UNAM working together. So it's quite a broad project, getting broader and broader. And we're tackling this fundamental issue, which is not just a Mexican issue, but as you can see, it will affect pretty much the whole of the planet. Over the next 50 years, 30 years, we're going to see massive changes in land use purely because we can't grow land there. It will be too hot, or there won't be enough water, and therefore we're going to have to either change the crops we're growing or change where we grow them. And that means less arable land in total, but also the problem of more people, more mouths to feed. So we'll have 35% more people and 70% more urbanization. So this is like the perfect storm, if you like, of a dire need for more food. Now, what about Mexico? So this is data from CIAT in Colombia, and they predict that for Mexico, this is historical bean growing areas in Mexico. And where it's green, it's pretty good, and where it's red, it's definitely not good. And this is predicted future yields if we use the varieties of bean that we've been developing over the past few years. Now, what we need to overcome the future CO2 issues that will cause increased incidence of drought and heat stress are even better beans to hopefully get to a situation where it's improved yields across the whole of Mexico. Now, you see in this future yield, there are some areas that do better, and that's because they're in the highlands and they're cooler, and at the moment, they're not so good for growing beans. So what we're looking at is a total area. And this is the same for Latin America as a whole, and also large parts of Africa. So it's a massive issue. Now, why beans? Well, beans are really high in protein, carbohydrates, minerals, and they're affordable for a large percentage of the population. But they're also highly sensitive to heat and drought stress, particularly at the flowering stage and pod set, when yield really counts. So I've been tackling the issue with my colleagues, focusing on stomata. And stomata are, and you see this little diagram here, these are little pores, and there's actually millions of stomata on the surface of a leaf. And they're involved in water uptake and water loss, and also CO2 uptake for carbon fixation for photosynthesis. And they're also involved in evaporative cooling. In the same way that humans sweat, plants release water to keep cool. And of course, with water uptake, you also get nutrient uptake from the roots. Now, legumes are particularly special. So beans, for example, they have symbiosis with bacteria in their root system. And these are rhizobial bacteria that produce nodules in the roots that actually fix atmospheric nitrogen. And that means that the farmer doesn't have to use so much nitrogen in their fertilizers for improved yields, because the plant does it for them. However, the rhizobia themselves are sensitive to drought and heat stress. And under drought, you rapidly get a loss of nitrogen fixation. So what we want to do, what we have the opportunity to do with this Newton Prize project, is to combine my stomatal expertise and my colleagues' stomatal expertise with a larger group from UNAM to look at improved varieties for both stomatal water use efficiency and nitrogen and nutrient use. So, as I was saying, this will employ across 3 Mexican labs, postdocs and technicians to work on this problem with a whole population of mutant beans, developed by the USDA originally, to obtain new varieties that can be used in agriculture for these issues. So we'll assess these as well in the University of Sheffield's unique climate change facility under elevated CO2, because we don't just have the problem of less water and more heat, but we also have the issue of more CO2 in the atmosphere, and plants respond very rapidly to changes in CO2. So this is also an issue that we need to get to grips with. So we'll identify these genes, these mutations, and from this population, we want to get the best plants to produce drought-resistant varieties for Mexican agriculture, but also for agriculture across the world. And Mexican agriculture has different needs to agriculture in East Africa, for example, and different varieties will be needed for different areas. So this is a fairly long process of plant breeding, which may take several more years. But eventually, we hope to improve rural livelihoods, both in terms of food security, economic security, reduced reliance on fertilizer inputs because of this rhizobial nitrogen fixation. And because of less fertilizer use, you have better water quality coming off of those agricultural lands. And obviously in the long term, Mexico will hopefully rely less on bean imports from the US, from China, and have much more economic security in terms of food costs. As I said, I'd like to thank Professor Gray and Professor Covarrubias for their continued support of this project, and also the new collaborators, Georgina Hernandez and Alejandro Sanchez, and of course my students, Coral and Brianda, and Tim Porch, who produced this population in the first place. And of course, the many funders, including the European Commission, that have supported our work. Thank you very much.
I'm really interested. What happens when you identify, let's say, what looks like a desirable phenotype for the purposes of your breeding?
Yeah.
How do you make sure it's not just to go back to Linnaeus, that it's not an epigenetic thing that you're looking at rather than a genetic change? Do you look at the genome of all these plants very carefully?
So we'll have the opportunity with Alejandro Sanchez here to look at the genome. He's an expert in genomics and transcriptomics and bioinformatics, and there we can walk to the genes involved in...
Because some of these changes may be epigenetic, but there's a response to the environment.
They could well be epigenetic as well, but that's not necessarily a bad thing.
No.
You can stabilize an epigenetic effect to some degree, and that's something we would have to work with, yeah.
Somebody asked, yes, just about to see it. Do you want to wait for the microphone? Hang on a second, because I've got time.
Are you also doing some work in field to see whether there are already plants that they are more stable and they are capable of working in these environments?
Yes, so what I haven't discussed here is the other aspects of the project that include looking at crop wild relatives of common bean and also other cultivars of common bean. So there are two Mexican crop wild relatives. One is the tepary bean and the other is a sister species from northern Mexico, where it is semi-arid and desert zones. And the indigenous groups from that region have been using these species in agriculture for thousands of years. The economics, the market-driven forces don't buy the beans, but those beans hold a huge wealth of genetic material that is being used by CIAT in Colombia and also Mexican groups to interbreed these traits as well.
Can you think, or do you think that this approach can be used for other legumes? I don't know, alfalfa or carob or something like that?
Without a doubt, yeah. And in fact, we're also using soybean to test some of our theories because some of the science is a bit quicker in soybean than it is in common bean.
Right. Yeah.
Yeah.
Thank you.
Yeah, is that...
Thank you very much. You're breeding your new varieties against a series of sort of climatic predictions about drought and heat.
Yeah.
And you're saying, you know, greater drought, more heat stress. But we also know there's high levels of variability in what is being projected and high levels of storminess, which may deliver you huge amounts of water in very short periods of time, as well as other factors to do with aridity. Yeah. So I'm just wondering whether you actually have the bandwidth in your genetic manipulations to deal with this whole range of circumstances.
So when many people think of Mexico, they think of it as a dry country. But within the 3 or 4 months of the rainy season, you have more water than the whole of the UK for the whole year. So these species have evolved within flooded zones and the cultivated, domesticated in areas of very high water. But you're right, we need to also grow for flood resistance just as much as for drought resistance.
I've got one last question.
Yeah, it's probably related to the question of the gentleman. Is there a role here for improved irrigation water management? Because one of the things you've said just now is that there's a period in which you have a lot of water. And if you actually educate these farmers to store some of this water and use it for irrigating when things are much drier, that could actually solve some of these problems. So what I'm saying is that, did you have any discussions with experts in irrigation water management on how to synergize what you are developing here and what you could get from improved water management?
I agree irrigation is an answer. Unfortunately, for many of these rural communities, it's not an option. The availability of the infrastructure is not there. And I mean, where I live in Mexico, at the end of the dry season, there are weeks when we don't have water in our house. So it's definitely needed, but irrigation technologies in arid zones require very careful inputs with regard to salinity, which those technologies are just not available for many people.
And presumably this is translatable to many other environments, of course, where you've got that kind of problem, like Africa, for example.
Of course, yeah.
Savenki, can I ask you? I'm going to ask you to present the Chair's Award.
So in addition to the individual countries prize, there's a Chair Prize, which the jury felt was something that was particularly interesting and particularly applicable beyond that country or that region. So something that might have global implications. This isn't to say many of these projects, I mean, drought resistance, for example, has global implications too. But this is after we had considered individual countries prize. We wanted to look for another project that we could pick out that was particularly important from a global perspective. And the one we chose has to do with a particular problem, which is that thousands of people around the world are imprisoned, tortured, or executed for political reasons. And left undocumented, these actions are often met with denial, revisionism, and impunity for those who commit them, threatening democracy, peaceful coexistence, and human development. So, examining the case of Chile and the unprecedented documentation work undertaken by civil society organizations during the Pinochet regime, an international research team has shown how the act of documentation itself is an important mode of resistance to human rights violations. Working closely with human rights advocacy organizations, Newton-funded researchers plan to increase the availability of information about human rights violations and inform policy and practice in this important area in other countries, including Colombia and Mexico. And so I would like to introduce and invite the winners to give their presentation. They are Vicky Bell, Professor of Sociology at Goldsmiths University of London, and Dr. Oriana Bernasconi, Associate Professor at the Department of Sociology at the Alberto Hurtado University.
Esta investigación surge desde el terreno, surge en Villa Grimaldi. El archivo oral de Villa Grimaldi, que está compuesto por testimonios de víctimas sobrevivientes, me pidió que revisara el material del archivo y ahí empezó a surgir la idea de hacer una investigación que examinara y problematizara la forma en que hemos registrado la violencia política perpetrada por la dictadura militar.
Thank you. In the days, weeks, and months following the military coup in Chile in 1973, the most intense period of violence and human rights abuses in the Pinochet dictatorship, people turned, as one would expect, to their churches and religious leaders for protection. Just days after the coup in October 1973, the Committee for Peace was established to provide a wide variety of support to those affected by these events. Its work was continued under its successor organization, which was inaugurated in Santiago in January 1976 by the Catholic Cardinal Silva Enriquez. It was called the Vicaría de la Solidaridad. Among the several tasks of support that the Vicaría undertook was the task of recording what they were being told, registering the repression and experiences of violence. If data means what is given, they engaged in the task of receiving the gift of information and presenting it in the form of tables, spreadsheets, and narratives, that is, as data in the way we generally understand the term. This role was to become crucial in providing a picture of what was happening in Chile, as the workers received the terrified stories from families, friends, witnesses, and those who had themselves been detained and tortured. The amalgamation of information from these individual stories was able to show the extent and the similarities of the experiences of the people who were contacting them. By gathering and circulating the data, the workers were able to make the systematic nature of the repression apparent, using the data as what we have termed a technology of resistance. Moreover, they were able to locate clandestine centres where the disappeared were held, find information about disappeared people for their families, and identify perpetrators who were involved. Certainly the work had enormous impact. The production of such information and documents was, needless to say, dangerous work, undertaken under the watchful eye of the Pinochet regime, which continued to intimidate and attack the organization, harassing the workers, arresting them, summoning them to court, and expelling or refusing re-entry to its workers.
This project has studied the extensive archives of the Comité Pro Paz and the Vicaría, where over 47,000 individual case files and over 80,000 legal documents are kept, as well as the archives of other major human rights organizations that emerged during the dictatorship period. And it has done so not only to offer recognition and to salute the courageous workers who undertook this labor, but also to show the important legacy of this work, to show how its decisions and processes enabled resistance and informed later understanding and proceedings. How violence is recorded structures the ways in which its occurrence, its patterns, its veracity survive in order to become known. Not least, these archives have been able to inform and substantiate important processes after the return to democracy, such as the official recognition of victims and reparation. The archives have informed numerous legal cases in Chile and elsewhere, including in 2016, during the life of the project, at the important Plan Condor trial in Buenos Aires. And they have supported many memorial and historical projects. Ours has not been a purely historical project, however, but an interdisciplinary one, gathering a team drawn from the disciplines of sociology, linguistics, psychology, literature, anthropology, law, the arts, as well as history. In order to foster a larger audience for the work, alongside the contributions to the open access timeline for human rights in Chile and the academic interventions and publications, the project also commissioned an artwork. La Sábana, by Nicolás Franco, took inspiration from the sheets of data collected by the Vicaría. Enfolding this into his own story from the 1970s, Franco produced a wall-sized artwork that, in its careful, subtle response, emphasized the personal lives behind and entwined with the data. In the photograph, you see the former workers and the artists standing in front of the work. In this next image, you see a detail showing the handwritten list of political groups to which the detainee disappeared belonged, as well as a photograph of the artist as a boy, emerging from behind the columns of letters. The Newton Prize will enable the project's findings to inform and provoke further conversations in Colombia and Mexico. There, we will be able to continue the work of considering how the registration of human rights violation is conducted and how it can be crucial for resisting the otherwise traceless practice of forced disappearance. By sharing experiences and detailed practices, the intention is to empower communities in ongoing struggles and aid understanding of their role in guarding against impunity and forgetting. Thank you.
Thank you. Are there questions?
Thank you. Are there any similar initiatives existing in Colombia and in Mexico, similar to what the Vicaría did in Chile?
Yes, indeed, and we've just recently actually come back from a research trip to Colombia, where we've been interviewing archivists and academics who've been involved with the National Center for Historical Memory, which shares some similarities to the Vicaría, but it's quite interesting for us to see how they're similar and different, and in particular how the ways of collecting information and data about violence is different in different places, but also has a different relationship to government policy and a different relationship to the infrastructure of government. So this is very exciting for us, and we're going to continue those conversations. Thank you.
So, how do you feel about the changes in government, in the last 5 years? I would say the trend is not optimistic. Right? I mean, do you have any?
Do you want to answer? Maybe you can answer in relation to the Valence Commission.
Well, which
Just thinking about the processes. So what's particularly interesting for us is in terms of transitional justice, I think, the different ways in which archives are involved or not involved in relation to that. And I think, of course, we always need political will to be on the side of the freedom of information, but different governments have taken different decisions about how open the data that is given should be and shouldn't be. And I think in Chile that's been very interesting recently with the last Truth and Reconciliation Commission keeping the data under embargo for 50 years. So that's rather different from the archive that the team has been studying, the Vicaria.
Which is available right away.
Yes, it's available if you go and visit. It's not available in the way that some of the work in Colombia, for example, is available digitally. Yeah.
Sorry, can I say something? Go
ahead, Ariana.
Yeah, I just want to add something to your question. I think that the comparison and to open the project into different countries will exactly allow us to see what other actors can do in relation to these archives. The situation in different countries is very different. In Brazil, they have had a Truth Commission now, a report, and the archives they produce are fully available in a website. So as you see, there are different ways of handling data in these cases. So it's very important to have a larger picture in order to provide of policy recommendations in these matters.
Your presentation and your historical project focused principally on abuses by government. In some places, the abuses are criminal cartels, for example. Have you found any insights as to whether documentation is relevant in defending against criminal abuses?
Yes, in the Chilean case, it has been used. Actually, the main user today of the Vicaria archive are the judges that are judging people for crimes against humanity. And it's because the information this archive kept, it belongs to the times where the crimes were made. So they are not reconstructions, so they have a lot of value for judicial purposes.
Yeah, I'm very, very impressed with what you've presented here tonight. Obviously, it has an enduring legacy. The work will go on into the future. My comment was really about Chile's loss was the UK's gain, because during the time when people, particularly young people, were leaving Chile, I was living in a city which received probably about 2,000 to 3,000 Chilean refugees. And they made fantastic contribution to society in that city, Sheffield. I mean, it was vibrant, interesting, but some of the stories told in the pubs and the social activities that the Chilean refugees told were just catastrophically awful, absolutely awful, torture and so on. Have you considered interviewing those people who left Chile, took up refuge in other countries, and perhaps went back?
We haven't, but there is a project undergoing in Warwick University, working with a UK archive of Chilean exiles related to the World University Service that provide university opportunities to people that came here as refugees back in the 70s. So there is an archive there, and they are now, more than 2 decades afterwards, interviewing these Chileans here and to try to reconstruct their lives during these last years.
This is a bit impertinent, really, but I must. I would just like to report an experience I had. I was collaborating with Dr. Croxato, or Professor Croxato, in the University of Santiago. And I was in Chile during the height of the regime. I was told I shouldn't go. And I remember on one occasion, one evening, being caught outside where I should have been, the hotel, at the time of the curfew, and we sat all night reciting poetry in this room. And I remember vividly my extraordinary impression of the resilience of the Chilean people that I met, my colleagues, and some of these people had actually had that violence. Two of them became colleagues when I went to the United States and I worked with them. They were, in fact, being chased by the authorities because they had actually found injured people who were hunted by the police, and because they treated them, they were then regarded as being on that list, but they actually escaped from Chile. But I just want to say how marvelous it was to hear you this evening, because I really bring back that memory, that remarkable, my first visit with Chile is still a very, very impressive one.
Thank you.
But I'm so bad at reading the script. I think we need all the prize winners back on stage for a group photograph. Is that right, Mark? That's correct, thank you. So if you'd come back on and have a group photograph with Cervenki.
So, ladies and gentlemen, just briefly to add my congratulations to our 5 winners this evening. Best of luck, obviously, with your future work that will be enabled by your share of this year's £1 million Newton Fund. Thanks to Cervenki in particular for his chairmanship over 2 years, which has been hugely generous of him, and to his committee members this year as well, who we are very grateful to Lord Winston for his comparing of tonight's events as well, to Professor Loughead for standing in at very late notice and doing an excellent job on behalf of BEIS, and to everybody here this evening for your attendance as well. We're very grateful to you for making the time. A reminder that next year we will have China, Indonesia, and the Philippines as our prize-winning countries. Yes, and keep following our Twitter and our other social media accounts to find out who our chair of that prize session will be. There will be further news to follow. But otherwise, thank you very much, and have a safe journey home this evening. And with our backdrop up here, if you would like any photos, we know that there are friends and diplomatic missions here. If you want some photos with your prize winners, then please do come up and use the stage. And we have our photographer remaining with us to take some photos for you as well.